Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome again and thank you for joining us for today's Oxygen Talk brought to you by the Oxygen Alliance. My name is Elizabeth Kabalaba, a biomedical engineer with the Oxygen Alliance, and I'm excited to be your host today. So the Oxygen Talk is a visual meeting where we discuss various topics related to medical oxygen. I am hosting this call from Lilongwe, Malawi, and I would like to know where you're joining us from. So by typing in your name and location in the chat. And if you want to be added in our emailing list and get notification of upcoming events by the Oxygen Alliance, please type your email in the chat. And today we have another informative presentation for you from biomedical engineers from OpenO2. So we have John Kabambe and Chimwemwe TSC. We are so privileged today also as we have another special guest, Mr. Pius Chalamanda, a biomedical engineer from the Kamuzu Central Hospital here in Malawi also. So these presenters are experts in the field of mechanical ventilators and will expound more on the technology behind mechanical ventilators. They will also share with us the common problems associated with these machines and how to fix them. And I encourage you to take notes as we look forward to hearing your questions and comments at the end of the presentation. So without taking much of the time, let me hand over the floor to John Kabambe to start off the presentation. Over to you, John.
Thank you very much, Elizabeth. As already mentioned, my name is John Kabambe, and I'm a biomedical engineer with the Global Health Informatics Institute under the OpenO2 initiative. And today we'll be having a presentation on mechanical ventilation technology. This presentation is going to cover the introduction to mechanical ventilation, why mechanical ventilation is important, the classification of mechanical ventilators, parts of a mechanical ventilator and its setup, the operation of a mechanical ventilator, ventilator modes, as well as maintenance of mechanical ventilators. Now, to start off, mechanical ventilation is the technique through which gas is moved towards and from the lungs through an external device known as a mechanical ventilator that is connected directly to the patient. This procedure is also known as assisted ventilation or artificial ventilation. Now, why is mechanical ventilation important? Well, mechanical ventilation is used to address various medical conditions such as respiratory failure, which is caused by conditions that affect the lungs, such as pneumonia and COVID-19. And in this case, mechanical ventilation is used to increase the delivery of oxygen to the patient's body, as well as to prevent the accumulation of carbon dioxide in the blood of the patient. In addition to that, mechanical ventilation is also used to relieve the patient of the work of breathing, which in turn allows the respiratory muscles of that patient to improve or to heal. And it also provides enough time for any underlying diseases or injuries to improve. Furthermore, mechanical ventilation is used during surgery, where general anesthesia is administered. Now, general anesthesia has been known to depress the respiratory system of the patients on which it is administered on. And this makes it very difficult for these patients to breathe adequately on their own. As such, mechanical ventilation is used to ensure that the patient is receiving enough oxygen throughout the whole surgery procedure. And to add to that, mechanical ventilation is also used on patients with brain injuries or conditions that impair the brain's ability to control breathing. And in these cases, mechanical ventilation is also used to ensure that the body is receiving the oxygen that it needs for normal body functionality. Now let us go more into the classification of mechanical ventilators. There are various subcategories depending on the settings and the modes of ventilators, but in this discussion, we're going to focus on the two major categories, which are positive pressure ventilators and negative pressure ventilators, as illustrated in the image below. On negative pressure ventilators, These are an invasive mechanical ventilation technique in which negative pressure is generated on the outside of the chest by an equipment known as an iron lung. The negative pressure is transmitted to the interior to expand the lungs and to allow air to flow in. So basically, this iron lung that I've mentioned is an equipment that covers the body, most specifically the chest area, and this is where it generates a vacuum or negative pressure. This negative pressure causes the chest cavity to expand or to move outwards, which in turn reduces the pressure in the lungs of the patient, forcing air to be drawn into the lungs. And when this negative pressure is removed or reduced, it causes the chest cavity to contract or to move inwards, creating a region of high pressure in the lungs. And this forces the air that was in the lungs to be exhaled or to be moved out. So basically, this is how negative pressure ventilators control the breathing of the patient. And this is the earliest form of ventilators. It was created in the 1800s. It was used to fight against polio. So due to technology evolution in the ventilator sectors, it is no longer used in most hospitals and most medical facilities. Moving on, we're going to discuss the positive pressure ventilators. These use both invasive and non-invasive techniques, and they work by increasing the patient's airway pressure through a face mask or endotracheal tube, and this causes the lungs to inflate and to deflate. Now, this is the commonly used ventilator technology nowadays, and it is basically going to be the central focus of our presentation as we proceed. Moving on, the advantages of negative pressure ventilators. These ventilators are able to preserve the natural breathing pattern and the cough reflex of the patient. In addition to that, they reduce the risk of infection, trauma, or damage to the airway or lungs, since it is mostly an invasive procedure. And they also improve the comfort and quality of life of the patient. On the other hand, negative pressure ventilators are of a disadvantage because the equipment itself is bulky, noisy, and very expensive. And they may not provide the adequate ventilation for patients with severe respiratory failure or high oxygen demand. They are also known to cause skin irritation, pressure sores, or circulatory problems due to the negative pressure that is applied directly on the skin of the patient. Now moving on to the advantages of positive pressure ventilators. These ones, they provide a more precise and reliable ventilation for patients with severe respiratory failure or high oxygen demand. They are also able to deliver different modes and settings of ventilation that suit the needs and preferences of the patient as well as the ventilator operator. They are also able to monitor and display the vital signs and ventilation parameters of the patient, as well as to alert for any abnormal or dangerous situations that might occur during the ventilation process. On the other hand, the disadvantages of positive pressure ventilators is that they interfere with the normal breathing pattern and the cough reflex of the patient. And they may also increase the risk of infection, trauma, or damage to the airways of the lungs because they can also use an invasive form of air delivery. Now let us move on to see the difference between invasive and non-invasive ventilation, because I've used these terms during my presentation, so it is only right that I describe them and I differentiate them. Invasive ventilation is a technique in which a tube connected to a ventilator is inserted in the airway of the patient. This tube can either go through the mouth, which is known as intubation, or through the neck, which is known as tracheostomy, as illustrated on the two images below. On the other hand, non-invasive ventilation uses a face mask or nasal high flow cannula that is connected to a ventilator. This cannula or mask has straps to tightly hold the mask or cannula to the head of the patient. And in this case, the ventilator then pushes air into the lungs. An iron lung, as I've already mentioned, is also another example of a non-invasive ventilation technique. Now let us move on to the applications of invasive ventilation. Where exactly is invasive ventilation applied? It is applied in conditions on patients who have conditions that cause respiratory failure, such as acute respiratory distress syndrome. It is also applied on patients who have a stroke, traumatic brain injury, or patients who are in a coma. And it is also used on patients who need general anesthesia or sedation during surgery, or they're in the intensive care unit. And as you may observe, the applications that I've mentioned, it's either the patient is unconscious or is sedated. Now, why is it that invasive ventilation is often used on patients in that condition? It is simply because invasive ventilation causes high discomfort, pain, and even irritation in the throat and the mouth. And this can trigger a gag reflex or a cough. These reactions can lead to tube displacement, aspiration, or even bleeding. Now, a gag reflex is a reflexive contraction of the throat muscles or the muscles at the back of the mouth whenever an object touches the back of the mouth or the throat. It is a protective mechanism against choking or aspiration, so it is literally a normal reaction. So to prevent these problems that I've mentioned, invasive ventilation is often done on sedated or unconscious patients as they have a reduced level of response to stimuli. Moving on to the applications of non-invasive ventilation. It is applied on patients or situations where there's less need for endotracheal intubation, where there's a decrease in complication rate of the procedure, as well as where there's a reduced duration of hospital stay. It is also used on patients with neuromuscular disorders such as polio or spinal cord injury, or those who have weak or paralyzed respiratory muscles. It may also be used on patients with obstructive sleep apnea or obesity hypoventilation syndrome. And these people have difficulty breathing during sleep. Reaching this far, I would like to call upon my colleague, Chimamwe to proceed with the rest of the presentation.
Thank you so much, John, for that informative presentation. Indeed, my name is Kamuzu Central, a biomedical engineer working with the Global Health Informatics Institute under the OpenO2 initiative. Now, let's talk about the main parts and setup of a mechanical ventilator. So to start, a mechanical ventilator has a number of key components. A typical ventilator will have input ports for medical air and oxygen, a hidden moisture exchanger, some just called it a humidifier, a positioning arm, user interface, and also a breathing circuit, and of course a test lung. Moving on, I'll talk about the block diagram of the mechanical ventilator and how air moves from the ventilator into the patient and out of the patient into the ventilator or to a scavenging system. Firstly, there is medical air and oxygen source, which provides a steady supply of air and oxygen. Then there is a blender. The blender's purpose is to mix these two gases. After the blender, we have an aspiration valve. When this valve opens, it lets in gas mixture, a fresh gas mixture from the ventilator into the patient lungs. Then we have a flow sensor. The flow sensor's purpose is to measure the amount of gas being delivered to the patient. From here, the fresh gas goes into a humidifier or the hidden moisture exchanger, which adds moisture and heats up the air to match the body temperatures. The body temperature, so that the fresh air gas matches the body temperature. Then from the fresh air travels through one of the Y connector legs of to the patient. So from the patient, the expiratory valve opens to let the exhaled gas to exit the patient lungs. Additionally, there is a PEP valve. So some just call it a PEP. In full, it's called a positive end expiratory pressure adjustment mechanism or valve. So this valve controls the pressure in the patient lungs at the end of the exhalation. So there's also a processor or a microcontroller which receives and sends signals to most of the mentioned parts in the diagram, which regulates key ventilation parameters such as tidal volume, inspiratory rate, and also inspiratory and expiratory times. Apart from these parts, the mechanical ventilator has also other elements like alarms, monitors, and also, of course, an oxygen sensor. So these work together to make sure the ventilator functions properly and the patient gets the right amount of oxygen. Next, I'll talk about the breathing circuit of a mechanical ventilator. So for the breathing circuit of a mechanical ventilator, this comprises of two main limbs. We have the inspiratory rim and also expiratory rim. You can see in the graphics the part that has shades of gray, that's the inspiratory rim, and the one that's in white is the expiratory rim. So the inspiratory rim is responsible for delivering fresh gas from the ventilator to the patient lungs during inspiratory phase. It typically contains a white piece. So the white piece is a component that directs the flow of gas towards the patient. So connected to the inspiratory rim is also an inspiratory valve, which controls the opening and closing of the limb during breathing cycle. On the other hand, for the expiratory rim, this facilitates the exit of the exhaled gas from the patient. So this limb is equipped with expiratory valve, which regulates the flow of air out of the system. So in cases where a positive end expiratory pressure mechanism is used, the PEP valve, the expiratory valve may partially close during exhalation while maintaining a positive pressure in the patient lungs to prevent alveoli collapse. So to enhance patient comfort, the mechanical ventilator also has a heat and moisture exchange, which I said some just call it a humidifier. It is often placed within the respiratory rim. So this heat and moisture exchange warms and humidifies the incoming gas, mimicking the natural condition that occurs in the upper airways of the respiratory system. So this helps to prevent the respiratory passages from drying out and also ensures a more comfortable ventilation experience. After talking about the breathing circuit, I now want to talk about the significance of the heat and moisture exchanger and also the PEEP valve, the positive end expiratory pressure mechanism. So I'll first start with the heat and moisture exchanger. So the heat and moisture exchange are essential components in the mechanical ventilation. So this helps to mitigate the potential adverse effects associated with delivering dry and unconditioned air to the patient. So in mechanical ventilation, when a patient is intubated, for example, the system bypasses the natural humidification mechanisms of the respiratory system. So high flow rates coming from the ventilator itself can lead to the rapid drying and removal of air or moisture from the air pathways in the respiratory system. So especially this happens especially at high flow rates, which results in dryness and also irritation of the respiratory mucosa. So humidification and heat exchange mechanism addresses these challenges by adding moisture and also conditioning the air. Now I'll move on to talk about the significance of the positive end expiratory pressure valve. So this positive end expiratory pressure valve helps in keep the alveoli. These are small air sacs in the lungs open at the end of the breathing cycle. So at the end of the exhalation cycle, you still want to have these air sacs open. So this prevents alveolar collapse and promotes alveolar recruitment, which improves the overall lung function. So next, I'll talk about the other part. This is the patient interface that's connected to the breathing circuit. So this is the endotracheal tube or tracheostomy tube. My colleague already explained that the endotracheal tube is pressed through the mouth or nose, or the tracheostomy tube is pressed through the neck into the windpipe. So this endotracheal tube is a flexible tube which is inserted through the mouth or nose into the tracheal windpipe. This placement ensures a direct pathway for air to enter and exit the lungs. Next, I'm going to talk about the controls and the interface, how users interact with the mechanical ventilator. So some ventilators feature user-friendly touchscreen interface, which serves as a central hub for clinicians or nurses to input and adjust ventilator parameters. So the interactive display enables easy navigation and also customization of settings, which at the end of the day enhances the efficiency of the ventilation process. For some ventilators, they have a combination of both knobs and buttons. For others, they just have the knobs and buttons and also the flow meters, which shows the amount of the flow rate of gas and also the pressure. You may have a pressure gauge somewhere. So in addition to this touchscreen interface, as I said, some ventilators are equipped with physical knobs and buttons that offer manual control options. So these elements provide clinicians or nurses with flexibility to make real-time adjustment easily, which allows quick and precise fine-tuning of ventilation parameters whenever it is needed. So after talking about the control panel and the interface, I'll move on to talk about the operation mechanism of a mechanical ventilator. So the basic operating principles of mechanical ventilator involves the initiation of breath, inspiratory phase, and also expiratory phase. So I'll mention and discuss each part in the following slides. So we'll start with the initiation of breath. So during initiation of breath, the ventilation process typically begins when the healthcare provider sets certain parameters on the ventilator based on patient needs. So these parameters may include tidal volume, which is the amount of air delivered with each breath, respiratory rate, so this is the number of breaths per minute, and also, of course, the fraction of inspired oxygen, which some just call it FiO2. So the ventilator is then triggered to initiate breath. This triggering can occur in two different ways. It's either patient triggered or time triggered. So for patient triggered, this is sensed by the patient effort to breathe. While for the time triggered, this is actually set at a certain time intervals by the clinician or nurses or whoever is working on the mechanical ventilator. So after talking about this part of operation, we'll move on to talk on the other phase of the operation, which is the inspiration phase. So for inspiration phase, once a breath is initiated, the inspiratory phase begins. So the inspiratory valve opens to allow the flow of pressurized gas, which is the fresh gas, a mix of oxygen and air coming from the ventilator into the patient lungs. So the ventilator delivers the predetermined tidal volume to ensure adequate exchange of oxygen and carbon dioxide in the alveoli. So when the clinician or the nurse puts pressure controlled or volume controlled on the interface, it's either the clinician will put a volume controlled or pressure controlled. So in pressure controlled ventilation, the inspiratory pressure is maintained at a set interval throughout the inspiratory phase. Or in volume controlled, the ventilation, the ventilator ensures the delivery of preset tidal volume, while the pressure can be varied depending on the lung characteristics of the patient. Next, I will talk about the expiratory phase. So after the inspiratory phase, the ventilator transitions into expiratory phase. The expiratory valve closes and the inspiratory valve closes actually, and the expiratory valve opens. So during expiration, the patient passively exhales, and the ventilator allows the air to flow out of the lungs. So the expiratory valve controls the release of gas, which maintains a positive pressure in the airways to support the lung function. So another thing I want to mention here is that the rate of expiration is also an important parameter, and it is influenced by factors such as the resistance of the patient airways and also compliance of the lung tissue, which is of course directly proportional to the elasticity of the lung. Next, I'll talk about ventilator modes. So mechanical ventilators come with various operating modes, and they can be broadly categorized into electrically driven ventilator modes and also manual ventilator modes. So these modes serve different purposes and are selected based on the patient condition and also clinical setting. So firstly, I'll talk about the electro-driven modes, then the manual modes. For electro-driven modes, we have volume-controlled ventilation, then pressure-controlled ventilation, and also we have pressure support ventilation. For manual ventilation, we have manual back valve mask ventilation and pressure-controlled manual ventilation. So let's start looking at volume-controlled ventilation. So in volume-controlled ventilation, the ventilator delivers a preset tidal volume, as I said earlier, with each breath, which maintains a constant flow of gas until a desired volume is reached. So the ventilator setting may include tidal volume, respiratory rate, and also, of course, the inspiratory and expiratory ratio. For pressure-controlled ventilation, the ventilator maintains a set inspiratory pressure, allowing variable tidal volume based on the patient lung compliance and also resistance. Then the ventilator controls the pressure during the inspiration, and the tidal volume achieved also depends on the lung characteristics of the patient. That's the resistance and also the lung compliance. Next, we are going to talk about pressure assist ventilation. So in pressure assist ventilation, the ventilator assists in spontaneous breathing by delivering preset level of pressure support during the inspiratory phase. So this is often used to support patients who can breathe on their own, but may require assistance to overcome resistance of the endotracheal tube or any other airway obstruction. This obstruction can be the endotracheal tube, may be due to asthma, the pathway of air is obstructed, or the tracheostomy tube itself. So next, I'm going to talk about the manual ventilator modes. So for manual ventilator modes, as already said, we have manual back valve mask ventilation. So in manual back valve ventilation, the healthcare provider usually uses a back valve mask, which is a device which is manually used to deliver breath to the patient. So this mode is often employed during emergency situations or where there is a need for temporary ventilation before intubation and also initiation of mechanical ventilation. You can actually see below the text in the slide there that we have a reservoir bag, self-inflating bag, and also, of course, the inlet of gas. Then we have a mask. While for pressure-controlled valve, this one, of course, is similar to the manual back valve mask, which is also set manually, but the difference is that this mode has a pressure limiting valve. You can actually see just next to the text here in lead is the PIP valve, and also there's also a pop valve here. So the only difference is that you have a limiting pressure valve for the pressure controlled manual ventilation, unlike in the manual back valve ventilation. So this mode may be used specifically in clinical setting where pressure control is desired. So reaching this far, I will hand over to our special guest of this talk, Mr. Pius Chalamanda, who is a biomedical engineer working with Kamuzu Central Hospital and has vast experience in maintenance and repair of oxygen-related equipment, including mechanical ventilators. Over to you, Mr. Pius Chalamanda.
Thank you very much, Chimwemwe, and thank you very much, John, for the precise presentation. Hello, everyone, and good afternoon. Once again, my name is Pius Chalamanda. I'm a biomedical engineer working with Minister of Health here at Kamuzu Central Hospital, Malawi. Good afternoon. Right, so I am going to take you through maintenance of mechanical ventilators. Okay, so we'll share the common problems that are associated with the mechanical ventilators that a biomedical engineer is anticipated to come across when working with mechanical ventilators. So first of all, we'll look at the power supply. On power supply, one can check the machine supply voltage. This is usually indicated at the back of the machine. As you can see on the picture, there is voltage range 220 volts, 50 hertz there. Yeah, so in other countries they use 110 volts. So if you have like here we use 220 to 240 volts, so that's fine. But when you have 110 to 115 volts, then automatically a step-down transformer will be needed in that case. So you have to check that voltage. Secondly, you have to check the top plug and power cord if it is intact. You may replace if there are some damages that are present on the top plug or the power cord. If it is still not working, then you can try to secure the top plug, secure it into the socket properly, because sometimes some loose when the top plug is loose into the socket, it might also not work. You may check the fuse, replace it if it is bent. Check or change extension, or you can also change the power socket. Ensure that the extension or the power socket is grounded. All right, so let's proceed with power supply. You can also check if there is an appropriate voltage on the socket or on the extension. You may use a voltmeter for that one. If a voltmeter is not present, you may also use some other methods, or you can use, for example, your phone charger. Some phone chargers have some LED lights. So if you connect it to a socket which has power, the LED light will come on, so you automatically know there is voltage there. If it's not, then you know there is no power, so you can try to change. You can also check power switch at the back of the machine, or a circuit breaker at the back of the machine. You can switch it on if it was off, or if the circuit breaker was stripped off, you can also reset it. You may also check the battery level. If it is low, then you may recharge, or if the battery is drained, then you can replace the battery. The battery is inserted for the purposes of backup. so that if you don't have power, that is grid, then the battery can take over to run the machine for several hours, depending on the power that is available in the battery. Ventilators, in this case, should always be connected to power because of the battery, so that it continues charging the battery. Okay, so let's continue looking at the common problems of ventilators. Now, this time around, we'll look at the gas source. So in the gas, you need to check if both oxygen and the medical air is available from source. Preferably, we use centralized supply, but in case you don't have centralized supply, you may use an oxygen cylinder or an oxygen concentrator to provide the oxygen source, or you may use a compressor to generate medical air for the purpose of medical air. So you can also check the gas hoses if they are in good condition. You may replace if it is damaged, or you can repair it. If, for example, a cylinder is used for oxygen supply, then you have to ensure that the oxygen cylinder is full, and also spare cylinders should be available. If an oxygen concentrator is used for the purpose of oxygen, then you may follow the procedures for repair of oxygen concentrators that was provided by Mr. Jimango before. So if a compressor, for example, is being used for the supply of compressed medical air, then you have to make sure that it is up and running. And also you have to check for any leakages if they are present and fix them properly. Check the compressor air intake filter. You may clean or replace it if necessary. You can also check the moisture trap and drain it. Let's proceed. Let's move on to personnel on the same common problems. Personnel here, I included this one because as far as biomedical equipment is concerned, there are some faults or errors that happen on the machine due to user not knowing how to operate the machine. So you have to make sure that any person who is using the mechanical ventilators should have the knowledge on how to use these machines. So user training is a very vital component in as far as ventilators are concerned. This is so because ventilators work with patients that are in critical condition, and for their life and safety, it solely depends on the functionality of these machines. So no try and error on the part of the users can be taken for granted. So you have to make sure that the users are familiarized with the operator's user manual before using the machine on a patient. For example, if the user is familiar with one type of ventilator, he or she should not take it for granted to say that he will be able to operate each and every brand that comes along. So user training and the user manual are always very, very much important before starting operating this piece of equipment. They also have to be familiarized with the alarm systems. The user should never ignore or mute the alarm before checking what is talking about. This is a life-saving machine, and anything happening, any alarms that comes in, they have something to tell the user. So they should never, never ignore the alarm before checking what it is talking about. Ventilators should not be placed on a combustible where there is any near any source of fire, because As we all know, oxygen is combustive. Okay, so let's proceed by looking at the ventilator itself as a machine. What are the common problems associated with the ventilator? We have to make sure as engineers that the general servicing of the mechanical ventilator is done at regular intervals. Check the condition of cooling fan and the fan filter. As you can see on the picture, there is a fan filter there. It is located at the back, at the rear of the ventilator. So you have to check it. If it is very dirty, you can clean it. If it is damaged, you can replace it. Run prescribed tests and calibrations before using a ventilator on a patient. This is usually done by the anesthetist running the calibration tests on the ventilator. This is very necessary, and they have to make sure, or you have to make sure that the machine passes all the tests that are run on the machine. Because if it denies one of the calibration tests, it means the ventilator is not good to be used on the patient. Check for any leakages within the machine. Check moisture trap at the back of the machine and clean if necessary. Check oxygen and flow sensors and replace if necessary. Some ventilators have their oxygen sensors at the front of the machine. So they have like a directional arrow. So you just hold it and then you turn it toward the direction of the arrow and then gently pull it out and then replace it with a new one. Depending on manufacturers, usually 1 year is the period that are given to most oxygen sensors that they have to be replaced annually. Or if not, then you can refer to the manufacturer's manual. Next, we'll look at the artificial airway. This one is, I want to talk about the patient circuit. So on the patient circuit, we have to check for any tubing disconnections, as we know that the patient circuit has a lot of connections. So you have to check if there are any disconnections or loose connections within the patient circuit, and then you can reconnect to avoid some leakages. So the cuff also, you need to check for any leakages in the cuff and replace if necessary. Check that there is no obstructions in the airway. Check for any incorrect placement of the tubing. Check for any oxygen. Check for oxygen sensor. Check it and replace annually if possible, as I've already said before. Check the flow sensors and replace if necessary. Check for patient circuit valve functionality and replace where necessary. You can also check for any kinking within the tubings and correct them if they are present. You can also check for the presence of any bitings that may cause some leakages within the patient circuit. You know, these patients are usually unconscious, so sometimes they can bite the tubings and then break them to cause some leakages. And these are not only, the mechanical ventilators are not only prone to this biting by the patients. There are also some probes of some equipment, such as patient multiparameter monitors, for example. There are ECG probes, there are SpO2 probes. They are all prone to this biting by the patients, so they need to be replaced periodically when that happens. Let's wind up with the common problems by looking at the humidifier. You can check the power cord if it is intact. Most humidifiers have their own power cord, so you can check the fuse, the top plug, replace if necessary. You can also check the functionality of the heating element. So like you can see in the picture, that one is the humidifier. So you can see that glass, that glass bottle, that one is the bottle now where you put water in, and the arrow, that's where the water level mark, and you can also rotate it like screwing sometimes, or you can even slot it there, and you can see there is that knob which has digits, so that is where you adjust the temperature of the heating element. Yeah, so you can also check, because sometimes it may be on the lowest position and then they assume that it is heating while it is not. So they can also report that it is 40 while they have turned the knob to 0. So all those things have to be checked. Check the bottle if it is intact, if it is not broken. If it is broken, you can replace. Check water availability whenever it is in use. So whenever it is not in use, it is advisable that there should be no water inside the bottle. Okay, so let's move on to main challenges in maintenance of ventilators that a biomedical engineer is most likely to come across when working with mechanical ventilators. So one of them is lack of adequate skills by the technician. As we have already said, these ventilators work on patients that are unconscious, and their life solely depends on this machine for them to survive. So we don't want a technician who doesn't know what he's doing. No trial and errors on this machine. It is very important that the technician is well trained. It might be on job training, it might be on job orientation, it might be a short-term course, or even a long-term course. Is very, very much important before you start operating these mechanical ventilators. Inadequate working tools and test equipment. This is very common in our workshops. Lack of spare parts and accessories such as patient circuit, filters, air filters, oxygen filters, compressor service kit, and tubings. So without these, it means even planned preventive maintenance cannot be possible without these spare parts. So they are very, very, very much important that they are kept in stock. Lack of adequate user know-how. The users may not know how to operate these machines, as I've already said before. So user training is very paramount, even refresher courses. Different brands, multi-branding is also very difficult for engineers to manage these mechanical ventilators. For example, if you have 5 or more brands of ventilators in your hospital, how are you going to acquire spare parts for all those brands? It's very difficult. Yeah, so at least you need to have 1 or 2 brands. That's very, very, very much important. But in our case here in Malawi, we have a lot of brands, so it makes it difficult for us to manage this equipment in terms of acquisition of spare parts and accessories. And not only that, you as an engineer, you may not be a jack of each and every gym. You cannot know everything. So you may not be able to fix or maintain all those brands. You will be good at 1 or 2 or 3, but you cannot be good at all those brands. So training will be paramount, and the hospital will be spending a lot, even the government will be spending a lot, sending people for training on each and every piece of equipment that comes along. It's very expensive to manage and to maintain. Okay, let's wind up. Routine maintenance activities for mechanical ventilators. Time is not on our side, so we have to replace air and oxygen filters, replace oxygen and flow sensors, as I already explained, service or replace the compressor kit. This is on planned preventive maintenance, which is supposed to be done quarterly, sometimes 6 months, sometimes annually, depending on the manufacturer. recommendations. Yeah, so you have to check or replace compressor kit. On compressor kit, we are talking about compressor for the compressor that generates medical air, and also the compressor for oxygen concentrators. They also have compressors. So on compressor kit, we are talking about both. Check and drain vapor traps at the back of the machine, on the ventilator or on the compressor. Check humidifier bottle if it is functioning properly and replace if it is possible. Check the tubings if they are intact, replace if necessary. Check the battery functionality, replace when necessary. Check the power cord and plug, replace when necessary, and also check and service the oxygen source. Whatever the oxygen source, it might be oxygen concentrator, oxygen cylinder, or the gas plant. They all need service at one point or the other. At that point, I thank you very much for being a very good audience. May God bless you. Thank you.
Wow, thank you, our engineers, for the wonderful presentation. Now the floor is open to questions and comments. And feel free to raise your hand or type your question in the chat, and I'll make sure that I acknowledge you and give you a chance to go ahead and ask your question. So please, if you have any questions, you can raise your hands and also type in the chat. So from the look of things, we have Goodlife Oboro. Your hand is raised. Please, you can unmute yourself and ask your question or comment.
Hello, can you hear me now?
Yes, we
Can you hear
can
me?
hear you.
Okay, yeah, I have a lot of questions to ask because I have about 2-3 brands of ventilators in my hospital. I have the Mindray, I have GE, either China G or something, and I also have this Bennett type, about three brands of ventilators. But however, let me ask, if the oxygen sensor fails, how do you replace them, or how often do you replace the oxygen sensors on the machine, on the ventilator? Then again, are we supposed, as biomedical engineers, are we supposed to know the how to set the different modes? Because one thing, the other day, I was installing the ventilator and I was confronted by the nurses. How do we maintain the machine? What modes do we put the machine on? So I was a little bit not too knowledgeable about the modes. So I want to know. That's why I took it upon myself that I must participate in this ventilator training. So I want to really understand how, if it's possible for a biomedical engineer to also know the different modes, not only the doctors, the biomedical engineers, can we know the modes? How do we educate the doctors and nurses in case we have a center where they are not too knowledgeable? And again, if there is any leakage on the machine, maybe the gas is not delivering, internal leakage, how do you trace it? How do you get to solve it? These are my questions.
All right. Good luck. And you have almost asked 3 questions. I hope they are clear enough. Engineers, I hope those questions are clear. So feel free to pick any of them and help them. Over to you, our engineers.
Thank you very much, Chair, through you. My brother, for example, on the oxygen sensor, for Mindre, for example, I'm not very much aware about the GE and the other one because it depends on the manufacturer. But some of the machines, they have their oxygen sensors at the front of the machine, but some they have their oxygen sensors at the inside the machine. So it just depends on the manufacturer, how they placed and where they placed their oxygen sensor. But for example, with the Mindre type of of ventilator, their oxygen sensors are at the front of the machine. So to replace the oxygen sensor, if you look, if you stand in front of the machine, to your left, down to your left, there is that oxygen sensor, and then you just get hold of it, and then you turn it toward the arrow. There is an arrow that goes anti-clockwise. So you turn it anti-clockwise up to the end, and then you gently pull it out. And then you get another one, you replace it, and then by replacing, you start from the same end, and then you turn it clockwise up to the end. Then you have replaced that oxygen sensor. That is as simple as that. But for the GE and the other brand you're talking about, I don't know actually the position of the oxygen sensor, where it is located. It might be inside. So when it is inside, you need to open the machine, and then you can replace it from inside. Just wanted to take that one. So on how often an oxygen sensor is supposed to be replaced. For MINRE, it is supposed to be 1 year. So yearly, you are supposed to replace the oxygen sensor. It's annual. So for the other brands, you can also check with their manuals what their manuals are saying as to how long they can be serviced. But usually it's 1 year you need to change, because if you don't change, it means on the calibration it will not pass. It will indicate, it will reject the oxygen sensor. It will tell that the oxygen sensor is faulty and it needs to be replaced, and there is nothing you can do about it. You just need to replace that oxygen sensor. Okay. On the mode, so what you do on the machine, for example, on MINRE, there is the service. There is service mode. So for an engineer, that is where you go into. So you can go into the service mode, and then you just follow the steps of each and every. You will find that all the necessary things are there. They are indicated. So you just check what you want. Whether you want calibration, you get it from there. Whether you want the oxygen calibration, you can only calibrate the oxygen sensor on its own. You want to calibrate the what? You want to check if there are any leakages. So in the service mode, that is where you can get everything an engineer wants. For internal leakage, again, if there are any internal leakages, the only way is to open the machine, and then you can listen to where the leaking is coming from. You can actually feel it. You connect the machine to either oxygen or medical air, and then you actually feel, or you actually hear the sound of the leaking part or the leaking tube. So you disconnect it, you take another tube, you connect. So that one you can access it from the inside. So you need to open the machine. I don't know if there is anything that I've missed, but as far as I understood you, that is some of the things you asked. If there is anything that you want more clarification, you can please go ahead. Thank you very much.
Okay, yeah, thank you, sir. You answered the question perfectly. Can you hear me?
Yes, I can.
Yeah, the questions were answered perfectly. Like I said, I have a lot of questions to ask. For instance, now how if, like you said, we should go for engineers, we should go to the service mode. Is that where we calibrate it will direct us on how to calibrate the sensor also, right?
Yes, yes.
Okay, okay. Then again, yeah, when it comes to, because I used to see different modes. Sometimes some ventilators, they have CPAP mode, some have same vein. How do you indicate, although we are not clinicians, but how do we try to direct medical doctors or nurses on the mode that you will place the ventilator? Just in case you have a patient that, or I didn't start from the beginning, but I had the inverse ventilation and the non-inverse ventilation. So I don't really know which mode do we place the patient, how do we direct them, and how do we set the parameters. For instance, what do they call it, the inspired oxygen, and then things like that. This, parameter setting.
Okay.
Thank you.
What I can say on that one, I may not answer your question very directly, but one thing that I may advise is that some of us, or us engineers, we may not be conversant to know each and every mode or details, because some of these issues, like the modes you are asking, those are the things the anesthetists are all trained on how to change. They know this mode better than we can. For us, it's just the servicing part. So for us to know those things much better, you can go to the chief anesthetist or somebody who is very much conversant, and then you work together with someone in the anesthesia who is very much conversant with that type of equipment. You ask them those questions. They will teach you on how to, like in my case, when I want to work on some of these ventilators, when it is something to do with operation, I usually ask one or two anesthetists, can you please help me on how to operate this one? So they will advise. They will say this one will operate like this, will operate like this. So you work hand in hand with them. So as they are doing that, you also learn. Secondly, you can, if you want to conduct, for example, user training, you can incorporate them. You can incorporate those ones to come in, so that they can assist their fellow friends on how to best use that particular piece of equipment. So if not, probably that all the anesthetists are not well conversant with the machine, then at least the user manual can provide more guidance. So you can just take the user manual, and then you go through the user manual, and then you check each and every mode. How do you set that mode? So they are all in those user manuals. So each and every brand of equipment, as you said, you have 3 of them. Each and every brand has a user manual. So how you go into those servicing modes, it's each and every user manual has those details as to how each and every one of them will work, because they will differ after all. I can talk about Mindre, but the other GE, for example, will have another mode of operation different with the Mindre, because these manufacturers, they differ in a lot, simply because they just want to stand alone. They don't want, like, I copied from Mindre, I copied from the, so they want to make their own things different. So the manual is the very much better guide to guide you on how to work on that machine.
Well,
So first of all, you take
I
that
told to change.
manual. Okay, let me just finish, just a second. You take the machine and the user manual, you go to your maintenance workshop, and then you go through the machine, and then once you have learned everything, you can then teach. You can now teach the doctors and all the nurses. I don't know if I've answered your question.
Yes, you've answered the question, but I was thinking, although yes, you answered the question very well. I was thinking, the engineers will also be trained on the modes also, but you've already given that clarification. Yeah. Then again, sorry, if we are doing the what they call the quick check, like a run, what they call it, pre-test, or yeah, pre-test, and if the oxygen sensor fails,
Calibration.
yeah, is that the calibration or the pre-test also? Once you put on the machine, it asks you to do a pre-test.
Yeah, the
Or is
calibration.
it, okay, that's the calibration. Okay, so if the oxygen sensor fails, that means it has expired.
Yes.
Or maybe it needs replacement or something.
Yes.
Okay, all right. So those are just the things now. Okay, all right.
Thank you very much.
Thank you very much, Gulag, and also Mr. Chalamanda, for the wonderful explanation that you've given to the audience. And this marks the end of this call. because of time. And thanks to our OpenO2 engineers for the wonderful presentation, and our special guest, Mr. Pius Chalamanda. It has been an educative session. So for all further questions, you can email us at info@oxygenalliance.org. And thank you for attending this call. As for now, goodbye.